Section 2.1. Section 2.1. We use the term function to describe this dependence of one quantity on another. That is, we say height is a function of age. We say temperature is a function of date. We say cost of mailing a package is a function of weight. So function f, the definition of a function, a rule that assigns to each element x in a set of A exactly one element called f of x in a set B. Basically, for every x, there is one y. Okay? So we can think of this. The domain is the set of all possible inputs. Anything that I can put into the function is my domain. Anything I can get out of the function is our output or our range. If the function is given by an algebraic expression and the domain is not stated explicitly, then by convention, the domain of the function is the set of all real numbers for which the expression is defined as a real number. So if we are finding the domain of each function, excuse me, the domain is basically, especially if you're given a fraction, think about what the denominator of a fraction is not allowed to equal. The denominator of the fraction is not allowed to equal 0. So what we're going to do is we're going to take each denominator and set it equal to 0 to figure out what the domain is not allowed to be. Okay? So if I have x squared minus x equals 0, I can factor out an x and get x minus 1. X times x minus 1 equals 0. Then I set each one of these factors equal to 0. So to solve the denominator, I get x equals 0 and x equals 1. What we figured out is what the domain is not allowed to be. Because if I take a 0, 0 squared minus 0, that's just 0. I get 1 over 0, not allowed to happen. If I take a 1, 1 squared minus 1, that's 0. 1 over 0, not allowed to happen. So our domain is all real numbers except for 0 and 1. And in interval notation, we say from negative infinity all the way to the left, as we're coming to the right, we get to 0. We have to stop and start again on the other side of 0. Then we get to 1, and we have to stop and start again on the other side of 1, where we then go all the way to infinity. Okay? Find the domain of the function. Again, another example. Enter your answer using interval notation. Well, if I look at the denominator, what is the denominator not allowed to equal? Well, let's set it equal to 0 so we know what it's not allowed to equal. I can factor this, x plus 3, x minus 2. I can set each factor equal to 0. If I subtract 3 from both sides, I get x equals negative 3. And if I add 2 to both sides, I get x equals 2. So these two things, when I plug them in, it gives me a 0 in the denominator. So those are where my domain is not allowed to be. So in interval notation, I start at negative infinity and get all the way to negative 3 and have to start again on the other side of negative 3 and get to 2 and start again at 2 and go all the way to infinity. And that is my domain for this function. Okay? What about if it's something like this? Excuse me. If I'm looking for something like this, I'm saying find the domain of this function. Well, in here, inside the radical, you're allowed to have anything except less than 0. We can't have a negative number inside because we need a real number as our solution. So this time I take what's inside the absolute value, inside the radical, and I set it greater than or equal to 0 because it has to be greater than or equal to 0. So if I subtract 2 on both sides, I get negative 5x is greater than or equal to negative 2. I divide both sides by negative 5, thinking about what we talked about last time. If I divide or multiply by a negative number, I have to flip my inequality sign, 2 over 5. So this is an inequality notation. Notice it wants it in interval notation. So I have to say everything less than or equal to 2/5. So from negative infinity to 2/5 with a bracket on 2/5. Okay? So when we get to a problem like this, find the domain and range of the function. Again, answers in interval notation. So if this is what it looks like, think about what shape this is. We could put it on our calculator and see visually what shape it is, or we could think about the fact that this is a parabola that has shifted up 1 and it has a vertical stretch of 8. So it's just a real steep parabola like this that has shifted up 1 from the origin. Okay? So domain-wise, how far to the left does this go and how far to the right? Well, it goes all the way. So negative infinity to negative infinity. What about the range? How far down does this go? Well, we said because of transformations that it comes up 1 from the vertex. So it starts at 1 and goes all the way to infinity because that goes on and on and on. Okay? Let f of x equals 3x squared plus x minus 5. Now we know this is a parabola, okay? But we're talking about evaluating functions, okay? For evaluating functions, remember, this used to be an x. Now it's a -2. So what we want to do is anywhere there's an x, we want to put in a -2, like that. Okay, you see how anywhere there was an x, I put in a -2? I put a -2 there and a -2 there. So I have to say -2 squared, that's 4. 4 times 3 is 12. Well, minus 2 and then minus 5. 12 minus 2 is 10. 10 minus 5 is 5. So this equals 5. So when x is -2, y is 5. Okay? F of 0, same kind of thing. Anywhere there's an x, I want to plug in a 0, substitute in a 0. 3 times 0 squared plus 0 minus 5. Well, 0 squared is 0 times 3 is 0, plus 0 is 0, minus 5 gives me a -5. So when x is 0, y is -5. Now, why do people freak out about this one? Because it's a fraction. We don't need to freak out about it, okay? We need to do exactly the same thing as we've done before. 3 times 1/4 squared, plus, or sorry, 1/2, sorry, plus 1/2 minus 5. Sorry, I was telling you the answer before we got there. Because 1/2 squared is 1/2 times 1/2, which is 1/4. So 3 times 1/4 will be 3/4. 3/4 plus 1/2 minus 5. Well, this is really 2/4 to get a common denominator, correct? So 3/4 plus 2/4 is 5/4. 5/4 minus 5. You can use your calculator, or you can think of getting a common denominator here with the 5. So 5/4 minus 20/4 would be -15/4. So this equals -15/4. So when x is 1/2, y is -15/4. Okay. Now this one's a little bit different only because it's just a variable. But we've done things like that before. Remember when we were checking for symmetry around the x-axis or y-axis or origin, we had to plug in a variable like this, a -x for x. Okay, so 3 times -x squared plus -x minus 5. -x squared is just x squared, so 3x squared minus x minus 5. This time we don't write it as an ordered pair just because of the fact that it's still an unknown, okay? Got it? So another function. This is what it looks like. It'll give you the function, and then it'll ask for all these different ones. And it'll give you a place for the answers for all the different ones, okay? Use some scratch paper or something like that to do your work, okay? So anywhere there's a t, I'd like to put in -8. So -8 plus 8 over -8 minus 8. Well, -8 plus 8 is 0. -8 minus 8 is a -16. So that's going to end up being 0. Okay. Let's see. 8 plus 8 over 8 minus 8. Uh-oh. 16 over 0. 16 over 0 is undefined. Or error. I think probably your calculator will say error, but it's definitely an undefined value because we cannot divide by 0. Okay, let's plug 0 in every time there's a t. 0 plus 8 over 0 minus 8. Well, this ends up being 8 over -8, which you know and I know simplifies to -1. Okay, let's see. Oh, this time it's just an a. So anywhere there's a t, I want to put an a. So a plus 8 over a minus 8. Well, there's no way for us to simplify that, so that is just our answer. Okay. This time we want to put in a squared minus 8 anywhere there's a t. Okay. So a squared minus 8 plus 8 over a squared minus 8 minus 8. Okay. So in the numerator, I have a -8 and a +8, so that's just 0. So all I'm left with is a squared. In the denominator, I have a squared minus 8 minus 8. -8 minus 8 is -16. So we have a squared over a squared minus 16. Remember, there's no way to simplify this. We can't just cross out the a squares because that would be super, super crazy. We're not going to do that. Okay. Last example on this page, a plus 1. Anywhere there's a t, I want to put in a plus 1. So a plus 1 plus 8 over a minus 1 minus 8. Oh, not plus, not minus, plus, a plus 1. Okay, so a plus 1 plus 8 is a plus 9, and a plus 1 minus 8 is a minus 7. Again, we can't simplify that any further, so we just get a plus 9 over a minus 7. Okay, hopefully you're doing okay so far. Another couple, a little bit different this time though. Okay, so I want to show you this example. 5x squared plus 4 is our function. Anytime there's an x now, I want to put in an an x plus 2. So I have 5 times x plus 2 squared plus 4. Now, I need you to remember that anytime we square something, it's the same as multiplying it by itself. So I have to distribute. I can't just say a squared plus 4. If I just say a squared plus 4, I'm going to be missing out on that middle term every time, and there's almost no chance I can get the answer right. Okay, so this actually is x squared plus 2x plus 2x plus 4, which gives me x squared plus 4x plus 4. So I have 5 times x squared plus 4x plus 4 plus 4 from right there. Okay, now I need to distribute my 5 here, here, and here, which gives me 5x squared plus 20x plus 20 plus 4. All that's left for me to do now is combine my like terms, which are these two numbers. That gives me 5x squared plus 20x plus 24. Okay? Now this one's a little different because there's two parts. First we have to do f of x. Oh, good, we already have it. And then we need to do f of 2. So f of x is just 5x squared plus 4. And I need to add to that f of 2. Well, 5 times 2 squared plus 4 would be f of 2, right? So I have 5x squared plus 4. Now I just go about simplifying what I can do. 2 squared is 4. 4 times 5 is 20. And now all I have left to do is combine my like terms here. and I get 5x squared plus 28. So you see how both of those were slightly different from the ones we were doing before? Okay. All right. A cell phone plan costs $39 a month. The plan includes 400 free minutes and charges 20 cents for each additional minute of usage. I doubt that any of you have to deal with a cell phone plan like this anymore. This is how they used to look. Okay, most of the time now you get free text messages or unlimited text messages or whatever, but this is how cell phone plans used to look. You paid one price per month, but that included 40 free text message or 40 free minutes, excuse me. And then if you had any minutes over that, you had to pay 20 cents per minute. Okay? The monthly charges are a function of the number of minutes used given by this function right here. So you paid $39 if your minutes were between 0 and 400. But if your minutes went over 400, you paid $39 plus 20 cents for every minute over 400. Okay? So we have to find three values here. We have to find C of 100, C of 400, and C of 480. Okay? So what we have to decide is, where does this fit? These are our parameters right over here. These are our restrictions. Okay, so where does 100 fit? Is 100 between 0 and 400, or is 100 greater than 400? Hopefully you see that 100 is between 0 and 400. So C of 100 is 39, just from right there. Okay, don't have to do any sort of calculations or anything like that. C of 100 is 39. All right, what about C of 400? Well, once again, I have to look and see if my value, my x value, does it lie in between these numbers or does it lie here? Okay, we're trying to find 400. This says x is greater than or equal to 0 and less than or equal to 400. Well, 400 is less than or equal to 400, so 400 also lies here with 39. Okay, now that was C of 400. Now, what about C of 480? Okay, well, C of 480, we have to look and see. C of 480. Is 480 between 0 and 400? It is not. 480 is greater than 400. So this is the part of the equation that I have to deal with. Okay, so I have to say 39. I have to actually do some calculations this time. Plus 0.2 times 480, because that's what I'm trying to find, minus 400. Okay, 480 minus 400 is 80, and 80 times 0.2 is 16. Well, now all I have left to do is 39 plus 16. So 39 plus 16 is 55. Okay, so now we've done all the calculations for here. Let's make sure we understand what it means in the context of the problem. Okay, if you use 100 minutes, you will pay $39. If you use 400 minutes, you will pay $39. If you use 480 minutes, you will pay $55. Okay? Hopefully that makes sense. Again, it's not probably a thing that you have to deal with because of your cell phone plan, but it's an interesting word problem to look at. Okay? All right. There's 4 ways to represent a function. Verbally, so with words. Algebraically, so with a formula. Visually, so with a graph. And numerically, by a table of values. Okay? We need to be able to go back and forth in between all 4 of these and know what things go with other things. Okay? So a verbal description of a function is given here. Okay? A verbal description is given here. To evaluate g of x, subtract 4 from the input and multiply the results by 4/3. That's the verbal description. Okay? I need you to be able to translate that into an algebraic representation. All right? So subtract 4 from the input. Now, what did we say earlier the input was? Let me see if I can find that slide real quick. right here, we said the input was our x value, okay? So if we subtract 4 from the input, that means we have the input and we are subtracting 4. And multiply the result, so we have to multiply this whole thing right here by 3/4. So this right here is the math sentence that represents this English sentence, okay? Now it says find a numerical representation for this function. So here's a table. If I know x is 2, I should be able to find the value of the function or the y value, okay? So if x is 2, 2 minus 4 is negative 2. Negative 2 times 3/4, so times 3/4 is negative 6/4 or negative 3/2, okay? If x is 4, 4 minus 4 is 0. 0 times 3/4 is just 0. If it's 6, 6 minus 4 is 2. 2 times 3/4 is 6/4 or 3/2. And if x is 8, 8 minus 4 is 4. 4 times 3/4 is 12/4, which simplifies to 3. Okay? Last but not least, find a graphical representation for the function. Okay? We have a couple options here. We could literally plug it into our calculator and press graph. Okay? Or we think about the points that we were just given on this table. Okay? For sure, 1, 2, 3, 4, I know that 4, 0 goes through this. Now, it'd be pretty rough for me to kind of sketch it right here, but we know it's a line because there's no exponents, so we know that it has an x and a y, so we know that this is a line, all right? As x is increasing, y is increasing, so we know it has a positive slope. And probably looks something like this if you put it into your calculator, okay? But again, we could definitely be more specific and look at those graphs and things like that if we wanted to, okay? So that is section 2.1.